Okay, once we're just going to measure the pressure in the pipeline, we have some situation that we have like a simple vertical measurements like this one on the left hand side. Imagine this like a cross section of the pipe. The measurement normally happens in a vertical gauge, but in some cases the vertical pressure or gauge is not possible, and we have to measure the pressure in the pipe with incline gauge. So in incline gauge, we can only just measure based on the gauging here. We can just with the measured here, we can just measure the like the incline gauge. So for that cases, how we can just carry on. The formula that we're just going to use for the vertical distance to the surface from the pipe is like the rho gz. In the incline situations, once we have this sort of things, we need to just calculate the vertical distance. And in this case, imagine this is like a triangle, and this is a hypotenuse. And for that case, we just calculate the vertical distance. The vertical distance is the hypotenuse times the cosine. If the angle to the vertical line is a theta, hypotenuse y times the cosine theta. So it's equal to the z, or the vertical distance. So we can just substitute the z on the left hand side formula and calculate the pressure. Let's look at the like one example here. We have inclined piezometer measure the pressure in the pipeline carries water. The piezometer is inclined at an angle of the 30 degrees to the horizontal line. Okay, angle of the 30 degrees to the horizontal. Just pay attention to this point. And has an inclined readings of 330 millimeters. So this is 330s. So what is the gauge pressure in the pipe? So it doesn't matter. You don't have to just use the formula that I said in the previous slide. The main and the most important thing is that you need to just calculate the vertical gauge or the vertical distance. With that kind of like the 30 degrees, the angle to the horizontal line, and the inclined readings or the hypotenuse here is like the 330 or 330 millimeters. Okay, so you need to just first calculate the vertical distance. So for that reason, if you're just going to use the formula in the previous slide, so once the angle is a 30 degree to the horizontal, the angle to the vertical, the angle of the pipe to the vertical is 60s. Okay, so 60. So if you're just going to use the formula that we used before, so rho g y cosine theta, so rho is like 1000, g is 9.81, and y is the inclined distance or inclined gauge. So it's like the and presented in meters, 0.33 times cosine 60. Cosine 60, it's like a half, and you can easily calculate this on the right hand side, and the answer pressure is like a 1619 newtons per square meter. In practice, we have different tools to just measure the pressure. So Bourdon gauge is one of these tools to calculate the pressure relative to the atmosphere. So this is like something that you can just see here and shows you the pressure in the units of the metric units, kilonewtons per square meter, or like the pounds per square inch. So this is something that you can see depending on the outer or inner measured. If you're just going to use that one, either the English or SI units, you can just use it. And something very important is that once you have the Bourdon gauge, you need to just calibrate that one. We're just gonna use there's a tool for that. There is by using a dead weight tester and using a normal the standard weights that we know that one, we can easily just calculate the calibrates the Bourdon gauge. So for example, in here, so the actual pressure is the weight here divided by the area. It's like the weight divided by the area. The area of this kind of the surface is noun because the diameter is given. So we can calculate the pi. If the diameter is given, pi d squared over 4, we can calculate the actual pressure, and we need to just make sure the measured pressure is equal to the actual pressure that we can calculate by this formula. And if not, there should be the screw or something behind this kind of the Bourdon gauge, and we need to adjust that kind of like the measurement. So that's the way to calibrate Gordon gate. Let's look at the last example for this session. We have the YouTube manometer. So the question here is to calculate the difference in pressure P1 minus P2. In this case, Z1 is 0.60, Z2 is 0.73, and HM is 0.13. So we have oil relative density of, for case 1 is 0.88, and for case B, to calculate this one, the difference of pressure for fresh water. So for the case 1, relative density like the 0.88, we need to just calculate this one. First of all, calculate the density of the oil. So it's more or less straightforward, but we're just going to see all the results here. For the first case, which is like the density of the water, density of the oil, we're just going to write the pressure XX in the left limb is rho O GZ1 plus P1. Raw oil is like 0.88 times 1,000. It's like if we can simplify it, write this one, which is equal to the density of the oil, times 9.81 times 0.6, which is a Z1, plus P1. Okay. On the right limb, we can write rho M GHM plus rho oil, rho O GZ2 plus P2. Rho M is 13,600 times 9.81 times 0.13. Okay, it's for this one. Plus rho oil is 0.88 times 1,000 times 9.81 times 0.73 plus P2. So the result is 23,646 plus P2. And on the left-hand side, the values are the same by equating the right-hand side, and we have this kind of like the equation. And by rearranging P1 minus P2, the answer is 18,466 newtons per square meter. For section B, in which the liquid is water in the pipe, so we only need to just use 1,000 rather than like the 0.88. So we can write the same relationship, and easily we can just calculate, and we can equate the right-hand side, and finally rearrange the P1 minus P2. We can easily calculate P1 minus P2, which is equal to 18,619 newtons per square meter. Just compare this figure with the previous one. The ones we have oil, the difference was 18,466. In this case, it's like 18,619. So it's like a little bit less once we have the water in the pipeline.